Hello viewers, this is Ronald taking you through today's tutorial on O-level physics, and this tutorial we're going to talk about the topic of magnets and magnetic field. This topic is taught in Senior 2 Term 3. That means that if you're in Senior 2, Senior 3 and Senior 4, this video will be of good benefit to you. Now these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 6. Question 6 came from UNEB 2006 paper 1 question 48, and it says a coil is wound on a soft iron rod as shown in figure 11. So this is figure 11. This is a soft iron rod and a coil is wound on it. So part A says describe what is observed when the key K is closed. So when this key K is closed, what is observed? So shall say that when the switch is closed, soft iron will be magnetized, and as a result iron filings will be picked up or attracted. So when you close this, it means that this one will get magnetized and these iron filings will be picked up by the magnetized soft iron. So if you wrote that, that is half a mark for being magnetized and another half a mark for attraction of the soft iron filings. So that gives you the 1 mark. So now shall go to Roman 2. Roman 2 says that describe what is observed when the key K is closed and then again opened. So when the switch is closed, the soft iron will be magnetized and the iron filings will be picked up as we saw in Roman 1. But when it is opened, the soft iron will be demagnetized, and as a result iron filings will start to fall off. So if you wrote that, you get yourself half a mark for demagnetization and another half a mark for the iron filings to start falling off. So that's how the 1 mark could come about. Now shall go to part B of this question. Part B says that state 2 ways in which the effect of what was observed in Roman 1 in a Roman 1 above can be increased. So they want this effect, in other words the effect of the soft iron being magnetized and the iron filings being attracted. How can it be increased? So we shall say Roman 1. So part 1 is by increasing the size of current. So when you increase the size of current, you increase the strength of the magnetization. You can also say that by increasing the number of coils around the soft iron. So when you increase the number of coils around the soft iron, it means that a lot of current also passes through the coil. They pass through the soft iron. Then also by using poles of a strong permanent magnet. So when you use poles of a strong permanent magnet, it means that the magnetic field strength will be increased. Then also by moving soft iron closer to the iron filings. So the closer the iron filings, the greater the effect of the magnetization force of the soft iron. So basically that's what they wanted, and let's see how marks can be awarded. So any of the 2 of these 4, you get yourself the 2 marks. So that was question 6. Now let's go to the next question. So question 7 came from UNEB 2004 paper 1 question 41, and part A says list 2 ways by which a magnet may lose its magnetic properties. So one of the ways by heating the magnet to redness. Another one is by placing the magnet in a solenoid connected to an AC. Remember, when it's connected to an AC is bidirectional, it goes to and fro. Therefore it will be magnetized and demagnetized at the same time, making it to lose its magnetic properties. Other ways could be by hammering, dropping, or hitting with I the magnet while lying in the east-west direction. Know that word, east-west direction. Another way would be by withdrawing it in the east-west direction while current is flowing. And also poor storage of the magnet can make it lose its magnetic properties. So if you wrote that, you'll get yourself the 2 marks. So now we shall go to part B. Part B says that the above figure shows an iron ring between 2 opposite magnetic poles, and Roman 1, sketch the magnetic lines of force on the diagram. So those will be the lines. I think realize that they don't penetrate this inner circle of the iron ring. So if you do that, that is 1 mark and for the field and 1 mark for the direction. Now shall go to Roman 2. Roman 2 says that explain what happens to the steel nails. So we shall say that the steel nails will get magnetized from the surrounding iron ring, and when you write that, that will be 1 mark. Now we shall go to question 8. Question 8 is good from UNEB 1996, paper 1, question 8, and part A says, what is meant by Roman 1 magnetic saturation? So we shall come and say that magnetic saturation is the limit beyond which the strength of a magnet can't be increased at constant temperature. Alternatively, you can say that this is a state where the magnetic material acquires magnetism to an extent that it cannot acquire anymore from the magnetizing source. So any of the 2, you'll get yourself 1 mark. Now we shall go to Roman 2. Roman 2 says that what is meant by a neutral point in a magnetic field. So we shall come and say that a neutral point is a point in the magnetic field where the resultant magnetic field strength is 0. So if you wrote that, that will be 1 mark. Now we shall go to part B. Part B says that an iron ring is placed between 2 poles of 2 permanent magnets as shown in figure 11. So this is the figure 11. Draw the magnetic field pattern set up between the 2 poles. So remember that this is an iron ring. So that will be the field. I think realize that it's moving from north to south, and it does not penetrate this inner ring or inner circle. So 1 mark for the field above, another mark for the field below. So that's how the 2 marks could be got in part B. So now we shall go to question 9. Question 9 came from UNEB 1990, paper 1, question 1, and part A says that the diagram in the figure 11 shows 2 identical bar magnets placed close to each other. Then on the diagram below, on the diagram, draw the resultant magnetic field pattern. So remember, magnetic fields run from north to south, so that will be the magnetic field pattern on the first magnet, and the ones connecting from this north of the one magnet to the north south of the other magnet will be as follows. Then these will be now the ones which range from the north to the south of the same magnet. So that is how the magnetic field will be. I think realize that here there is attraction, but here there is repulsion, because these are like poles and these are unlike poles. So basically that's the field pattern they wanted, and let's see how marks can be awarded. So half a mark will be for drawing the field pattern from north to south of the same magnet. So these field lines are from north to south of the same magnet, so that is half a mark. Another half a mark will be for drawing the north field pattern from north to south of the same magnet, so north to south of the same magnet, that is also another half a mark. Then showing the attraction between the north and south poles of the different magnets, also another half a mark. And showing the repulsion field line pattern for the south and south of different magnets, also be another half a mark. So basically that's how the 2 marks could come about. Now let's go to part B of the same question. Part B says that explain each of the following observations. So Roman 1, a magnet not stored in soft iron keepers becomes weaker, and they give it 1.5 marks. So you come and say that a bar magnet loses its magnetism due to self-magnetization. So self-magnetization starts at the ends of the magnet, where free like poles of dipoles repel each other and slowly upset the alignment of molecular magnets inside the bar magnet. So that explains why it becomes weaker. Therefore, half a mark for self-magnetization, demagnetization, half a mark for dipoles repelling, half a mark for slowly upsetting the alignment. So that is how the 1.5 marks would come about. Now we shall go to Roman 2. Roman 2 says they want to explain why heat destroys magnetism. So when a magnet is heated, molecules vibrate with greater energy, and these increased vibrations destroy the alignment of tiny magnets in the domain, and the magnetism is destroyed. Remember, when a material is magnetized, all the dipoles are aligned in the same direction. For example, here all the dipoles are in the same direction to the left, here all the dipoles are in the same direction upwards, here to the left, and here downwards. So in each of these magnetic materials, it means that they are well magnetized. Now this is how they will be before heating, but when you heat, the alignment is distorted. I think you can see here some are going facing the left and others are facing downwards, meaning here the magnetism has become weaker. The same applies here, some to the right, others to the left, and others upwards, meaning it is weakened, and same applies to this. So basically that's why heat destroys magnetism. Now let's see how marks can be awarded. 1 mark for molecules vibrating with greater energy, another half a mark for destroying the alignment, another half a mark for decrease in magnetism. So basically that's how the 1.5 marks could come about. So that has been question 9. Now let's go to question 10. So question 10 was got from UNEB 1988, paper 1 for question 2, and part A says the diagram below shows 2 identical bar magnets placed close to each other. So these are the bar magnets placed close to each other. Then they want you to sketch the resultant magnetic field pattern, and they give it 2 marks. So remember, magnetic field lines run from north to south. That is why here they run from north to south. Now this is outside, then with in between that will be the field pattern. I think we realize that the spacing has reduced. Here the spacing, they are more closer, and here they are further apart, the field lines. So what you do this side, you also do the same on the other magnet. So this also, the spacing will be closer, but outside it will be well spaced. So this is unaltered, the one passing through the axis of the magnet. So what you do this side, you also do this side. So we shall also draw that field line which is unaltered. So this will be another way, will be like that. So what you do this side, you also do this side. Then the same applies to this side also. And what you do on this magnet, you also do on this magnet. So basically those are the field lines, but they have a neutral point. So that will be a neutral point this side, and also the other side there will be a neutral point. So after drawing that, we shall come and label what does that symbol mean. So you come and say that the symbol denotes neutral point. So basically those are the field lines they wanted, and let's see how marks can be awarded. So have a mark for field lines from north to south of the same magnet. Field lines from north to south of the same magnet. Then showing that repulsion, also another half mark, another half a mark for showing that repulsion. So basically that's how you could get the 2 marks. Now let's go to part B of the same question. So part B says that name 3 ways of demagnetizing a bar magnet. So one is by hammering, dropping, hitting the magnet while lying in the east-west direction. Next, by hitting the magnet to redness. Another one is by placing the magnet in a solenoid connected to an AC, alternating current. So another one is by withdrawing the magnet in the east-west direction while current is flowing. And lastly, poor storage of the magnet can also make it lose its magnetism. So basically that's what they wanted, and any 3 of these ones you get yourself the 3 marks. So that was question 10. Now let's go to question 11. So question 11 says sketch the magnetic field pattern between the north-south poles in the figure below. So this is the south pole, north pole, and this is the soft iron. So the field pattern will be in that form, running from north to south. Half a mark, full mark for the field lines, and full mark for the correct direction. So basically that's how the 2 marks could be got. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of structured questions, by this time on the topic of force on a current carrying conductor. So this topic is still under magnetism, but the section is force on a current carrying conductor. So if you have not yet subscribed, please click the subscribe button below this video. And this topic is mainly for senior 4 term 1. So senior 4 students, you are at par. So that brings us to the end of this lesson. Thank you for watching, and be reminded that the solutions to the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can be notified when the next video with the solutions has been uploaded. Otherwise, thank you for watching, and if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook, WhatsApp, so that we all benefit as a family.